All right, guys, to finish up this unit, we're going to look at limit-based continuity. So as always, as we begin here, give the video a pause if you haven't had a chance to try it, so that we can then go through the bell work here, okay? And if you've already done it, awesome. Check and see if you did it right. So what we've got here is that we've got the limit as x approaches a of f of x is L, and the limit of g of x as x approaches a is M. So when we're combining these things, as we learned in our last lesson, we can separate this into three separate limits. And in doing so, this would, of course, just be L, because it told us that. This one would also be L, and this one would be M. Or we could say 2L minus M. All right, then down here on this next one, the constant is just a constant. It doesn't actually do anything. And then these are L and M. We could separate them into two separate, so we'd get 2 times L over M, where L and M are just the limits, the answers. All right, hopefully you got those right. And let's take a look here and jump down into limit-based continuity. So we've got a function here, piecewise function, obviously. And what we want to do is figure out three different things to figure out, is this function going to be continuous at a, where a is any value of x. So the first thing that we need to know is we need to know that g of a is defined. Because if the function doesn't exist, well, then it can't be continuous. Then we need to know the limit as x approaches a of g of x has to exist. Okay, so the limit also needs to exist. And then we need those two things to be equal. So we need the limit as x approaches a of g of x needs to be equal to g of a. If all three of those things are true, then of course our function is going to be continuous at that point a, whatever a is. So let's take a look at a few of these now. Is the function defined? If so, what is the value? So if a is -6. So if we look up here at -6, the function is not defined. Okay? What is the value of the limit from the left? From the left, we're approaching 5. From the right, we're also approaching 5. And therefore, the limit itself is 5 because the left and right side are equal. And is it continuous? No, it is not, because it was not defined at the very beginning. Okay, next one. -3. So at -3 here, it is defined, and it is 2. From the left side, we're going to approach that 2. From the right side, though, we're way down here, and we're going to be approaching -4. That means that there is no limit because the left side will not equal the right side. And so is it continuous? Well, no. We had to pick up our pencil to get over to the other side because the limit didn't exist. Next one is going to be 0. So if we look up here at 0, we can see that it's defined. We can see that from both the left and right, we are approaching the same thing. So let's fill that out. At 0, it was defined, and it was -1. From the left, it approached -1. From the right, -1, which means the limit is -1. And yes, it is continuous, which we can see very easily, right? That's why we're doing it with a graph the first time. All right, next one's going to be 2. So if I look up here at 2, right off the bat, we can see that it's not defined because it's an asymptote. So to learn a little bit of a trick here, what we can do is say, well, what is the value? Non-existent, therefore it is not continuous. Let's go through the rest of it anyway, just so that we can kind of see, but it's good practice. So from the left side here, we're approaching infinity. From the right side, we're going down to -infinity. So infinity, -infinity, therefore there is not going to be a limit either. All right, now 6. Sorry, let's clarify that. So why was I immediately able to say no? If any of those things were not true, any of these three, then we know that it is not continuous. We don't have to show all of them. We're doing it for practice, but as soon as one is false, it's not continuous. Okay, so x equals 6. So now we're here. So we can see that it's defined. And it was, I already lost it. It was at 1. Now we can already see that the limit is not going to exist. It's two separate ones, right? Because from the left, we're approaching 4, and from the right, we're approaching -2. That means that we've got 4, -2. Those two things are not equal. Therefore, there's no limit. Therefore, it's not continuous. All right. Last one here is at 8, right here. So you can see the function exists, and our limit is going to exist, because in both cases, the limit is approaching -2, even though the function is -4. So the little dot was at -4. The left side and right side were -2. Those are equal. Therefore, the limit is -2. However, it is not continuous because these two things also needed to be true. That was our third point there. So since it fails that one, it is not continuous. All right. Take a look at another function here. We got g of x, which is, of course, another piecewise function. And we've got several values where it is not continuous. Okay, we're going to use our three-part definition to figure out if it's continuous or not. So at x equals -8 here. So we don't actually need the graph necessarily, other than to find our values. But this is the idea, is we're trying to get to a point where we don't need to look at it, because we can look at it and tell really quickly if something is continuous. So the first thing I have to do is the function needed to be defined. And at -8, it is defined, and it is 4. Then I needed the limit, the second point, as x approaches -8 of g of x to exist. And if we look up here, as we approach -8 from the left and right, it does exist, and it is -5. Therefore, we can see here it's going to fail the third one because g of -8 does not equal the limit as x approaches -8 of g of x. Why? Because, well, 4 does not equal -5. Therefore, it's not continuous. So it's not continuous at x equals -8. Okay. Next thing here, we got to do it at 6. So first thing we got to do is find g of -6. And if we look up here, it does exist. It's right here. It is -7. Then we need that limit to exist, so the limit as x approaches -6 of g of x. And from both sides here, we can see that we're approaching that same point, -7. Oops. And so the last thing is those need to be equal. We can see that they are. I'm going to write it out longhand. However, you do not need to do this every time. But g of -6 is equal to the limit as x approaches -6 of g of x, because in this case, they are both -7. Therefore, it is continuous. So g of 6 is continuous at x equals -6. All right. Last one here we're going to do is -4. So first thing we need to do is find g of -4. That looks like a 6. Let's fix that. G of -4. And if I'm up here and looking, I can see that, yes, it exists, and it is -5. The limit as x approaches -4, looks like a 5, there we go, -4 of g of x. This is where we're going to have a problem, because from the left, it's approaching -5, but from the right, it's approaching -2. Therefore, this does not exist. If it doesn't exist, that means, well, because the left side didn't equal the right side, therefore, g of x is not continuous at x equals -4. Because it's not. They are not continuous. Okay. Let's take a look at some other examples where now we're going to remove the graphs that we actually need to do that algebra that we were doing. Hasn't changed the way we're doing it. All it is that now we actually need to do it without having the graph to be able to easily confirm if something is continuous. So our first step here is we're just checking at 2, which makes sense because here we can see we've got 3 different functions at x equals -2, whether it's on the left, the right, or at -2. So we need these things to be equal here. So first thing we're going to do is we're going to make sure that the function is defined. So f of -2. At -2, we use this middle function, so it is clearly defined because it is simply going to be plugging -2 into that middle function, and it gives us -4. So it's defined. Then we need to know if the left and right side are equal. So we need to know if the limit as x approaches -2 of f of x exists. So in other words, we need the left side, question mark, to equal the right side. Well, the left side would simply be when x is smaller, and the right side would simply be when it's bigger. So we're going to compare the top and bottom function there. And we're going to do it at -2. So the left side becomes -2 square root of -2 plus 6. And we want to know, does that equal the right side, which is e to the -2 plus cosine of negative 2 pi. Okay. This here, negative 2 plus 6 is going to be 4. Square rooted is 2. So this is just negative 4. That's good. On this side, though, we don't even really need to work this out to see. But this is going to be e to the negative 2. Let's see, cosine of negative 2 pi is going to be 1. So plus 1. This cannot be negative. It's impossible. And so if that cannot be negative, that means that these things are not equal. And so therefore, f of x is not continuous. Kind of lagged out there. Continuous. There we go. At x equals negative 2. Okay, so easy enough. Like I said, same thing, just taking away the graph. Okay, now let's look at this next one. So g of x, we're always going to start it the same way. So first thing is, does g of pi exist? Now here, there isn't 3 functions, but it still has the equal on the bottom one, so we use that one. And so it's going to be e to the pi tangent of 3 pi over 4, which of course exists. Let's see, that's going to be 3 pi over 4, that's going to be negative 1. And so we get negative e to the pi. Okay, so it exists. Then we need to figure out if the left side equals the right side. So the limit of g of x as x approaches pi. We just make those two sides equal to each other. So e to the pi cos pi equals question mark e to the pi tan of 3 pi over 4. Now luckily this left side, or the right side, we already know what that equals because we just did it. It's negative e to the pi. So we just need to make sure that this one is the same. So e to the pi cosine of pi is negative 1. And so indeed these things are equal. Negative e to the pi is equal to negative e to the power of pi. And so we can say that g of pi equals the limit. This is my justification as x approaches pi of g of x, which is equal to negative e to the power of pi. So g of x is continuous at x equals pi. Good. All right. Moving right along here, we've got a new function here, and we're going to figure out if this thing can be, actually, I think for this one, we're actually going to force it to be, sorry. What two limits must equal in order for f of x to be continuous at negative 1? Well, at negative 1, it needs to be the two that are on either side of negative 1, so it's those two. So it needs to be the limit as x approaches negative 1 from the left of f of x, and that needs to be equal to the limit as x approaches negative 1 from the right of f of x. Okay? And what two need to be equal for it to be at 3? Well, that's going to be the other two, right? This time it's those two. So that's going to be the limit as x approaches 3 from the left of f of x. And it needs to be true that it is equal to the limit as x approaches 3 from the right of f of x. Now we need to figure out what m and k need to be in order for that to be true. So what we're going to do is set this up as a system of equations by literally taking what these two things are. So let's take these two first here. So it's the left and right of 1. Well, the left was simply 2, and the right was mx plus k, but we're going to do it at negative 1. So that means it's going to be m times negative 1 plus k. And then I'm going to rearrange that a little bit because it's not really easy to read it that way. Good. Then we're going to do the next two, which are the ones at 3. So now, except that this time instead of x being negative 1, it's going to be 3. So this is going to be 3x plus k needs to be equal to negative 2. Okay? So then what we can do is we can take these two and, oh, not 3x, sorry. That should have been 3m, my bad. Now we can take these and we can put them together here. So I'm going to say negative 2 is equal to 3m plus k. Now, why am I doing that? Because then, of course, if I've got these two things, I can put them together in order to figure out, like, create a system of equations, I guess. So what I'm going to do is I'm going to subtract those, which means that this becomes positive, this becomes negative, and this one becomes negative. Because now, when we see this, we can see, okay, the k's are going to cancel. So 2 and 2 is 4. And negative 3m minus 3m is going to be negative 4m. And the k's are now gone, which allows me to solve for for m. And so I'll get that negative 1 is equal to m. Once I've got that, then I can plug it into either of my other equations and find k. So let's just do this one here. So I've got negative 2. Actually, I might as well do it in order. 3 times negative 1 plus k is equal to negative 2. So I've got negative 3 plus k equals negative 2, which means that k is going to be equal to 1. So I get that k equals 1, m equals negative 1. And if that is true, then we know that this thing will be continuous everywhere because we've literally forced it to be. And so that's it. That just gives you then the chance to do the practice problems there, guys. So go ahead and give those a try, and we'll see you next time.